Hello, everyone. It's Alan Schimmel, DevOps.com, and you're listening to another DevOps webinar. We have a fantastic webinar lined up for you today. I think you're all going to love it. But before we start, just real quick, we do use the GoToWebinar control panel or the GoToWebinar webinar system here. For most of you, that means you have a control panel somewhere on your screen, usually the upper right-hand corner. We have just two fantastic speaker panelists today, Anders Wallgren and Gene Kim, more about them in a second. But they've agreed to set aside some time for questions. We'll try to do as many questions as we can, but with almost 2,000 people registered to this, I assume we're going to have a lot of questions. So I'm going to ask you to type your questions in real time. If you look at your control panel, you'll see the little section marked questions. Click on the arrow or caret so that it's downward facing. And if you do that, you can actually go in real time and type your questions in, they're queued and ready for when we get to our question section. And you will not have to worry about remembering your question, fighting the question frenzy at the end of the webinar or anything else. So please type your questions into the question area so we can queue them up and prioritize them and have Anders and Gene answer them. Secondly, if you're having any technical difficulties, perhaps the audio is not working, the slides are not advancing, or something else, but you're still able to get to the chat section of your GoToWebinar control panel, we do have engineers standing by who can help you try to get the best experience possible out of today's webinar. So type your problem in the chat, we'll reach out to you and we'll try to make that happen, make it work for you. I see we're already getting questions in, and that's fantastic. But before we get to them, let's turn to our webinar. So today's webinar is sponsored by our good friends at Electric Cloud, and many thanks to them for sponsoring. It's titled, today's webinar is titled 10 Do's of DevOps, Key Technical DevOps Practices That Will Transform Your Whole Organization. Both of our panel members really need no introduction to the DevOps crowd. First of all, I'm happy to be joined by my friend, author, researcher, strategic advisor to Electric Cloud, thought leader, and founder of IT Revolution, which has become a bit of a empire unto its own, Gene Kim. Gene, welcome.
Alan. Good joining you. I prefer just author.
All right, I could have stopped at author, but Gene, I was on a roll. Joining Gene is the CTO and kind of one of the, to me, one of the leading voices of DevOps in this whole space and has been for a while. Always a pleasure to have on here in our webinars, Anders Wallgren. Anders, welcome.
Thank you. Great to be here.
Absolutely. Guys, and a quick reminder to the audience, if you're following along on Twitter, you want to comment, hashtag EC Webinar, Electric Cloud Webinar, EC Webinar, and we'll try to, grab some of those in if we can as well. So today's agenda on 10 Do's of DevOps. Why do we talk about technical practices for DevOps, right? And our panel will explain that. We're going to jump into Gene and Anders' 10 Do's for DevOps, and then hopefully we'll have some time to summarize this and a decent amount of time for questions and answers from the audience. So that's what we're aiming for. Hopefully we'll get there. With that, Anders, are you ready to take over?
Absolutely.
All right, go ahead, gentlemen.
I'll take over with Gene here. So, starting with this slide, which is really kind of the why are we here slide. These are some of the statistics out of the 2018 DORA Accelerate State of DevOps report, which if you haven't read it and if you don't make other people read it, you should, because it's a great resource in terms of research and analysis of kind of the problems and the successes and the failures and the tribulations and all those sorts of things of thousands of people in the industry, and the numbers have been fairly consistent and kind of getting bigger over the years in terms of organizations practicing DevOps are shipping more code, reducing lead times, shipping with fewer defects, recovering faster from failure, because failure is always an option, and in general make software more secure as a result of that. And so it's there are a lot of technical practices around that, and the 10 ones that we're going to talk about today are not necessarily the end all be all. We could probably come up with a list of 100 if we spent an hour on it, but we chose 10 to talk about that are kind of interesting. So Dean, anything you want to add to that?
Yeah, this is year 5 of the State of DevOps report. That was 2018, and I'm so pleased to announce that as of this morning, we just announced the launch of 2019 State of DevOps report, and so this is the first report that DORA is now doing under the auspices of Google Cloud. So I'm delighted that the adventure continues, Anders.
It's great. I mean, it's my favorite thing to put in front of people when they say, DevOps, does it really work? So it's always been a great resource. And sort of a little bit more on it, and this is again a little bit more pulled out of that report, but why are we focusing on technical practices? I mean, there are lots of different things to focus on in DevOps. I mean, culture, people, process being kind of the 3 main legs of the stool, if you will. But technical practices are those are the things that we do on an everyday basis, right? These are the things that kind of move the ball forward. People and culture is probably the most challenging, and probably also in some ways the most important thing to address in an organization. But you really have to focus on how are you doing things, and how do you change how you do things. And I was talking to a couple of people at work about this when we were getting ready for this webinar, and one of them brought up a great kind of analogy of culture, which was if you want to take somebody camping who hasn't been camping before and may not like camping. I have a friend of mine whose spouse went camping once, and she came back and said the only good tree is a stump. You want to think about how you can create a soft landing for that new experience. How maybe you don't want to go out in a Boy Scout pup tent when it's raining and you've got old sleeping bags to sleep on. Maybe you want to kind of gently move into that new way of doing things a little bit, and that's a little bit relevant here too, in terms of when you're doing technical practices, think about how you're introducing these things, and what the transitions are, and how you can get quick wins, and those kinds of things. Gene, what do you think about that?
Yeah, so just 3 very brief things on this. This diagram is one of my favorite diagrams of all time. It shows up in the Accelerate book. This is an updated one that showed up in the State of DevOps Report 2018, and we call it the BFD, the Big Fulsomely Researched Diagram. Every time you see an arrow, that is a predictive factor. 2 is exactly as you said. DevOps outcomes are really created by 3 things: architectural practices, technical practices, and cultural practices. And I think technical practices are also interesting because as Dr. Edgar Schein said, who studied the Toyota production process. He studied helped create the learning organization body of knowledge. He said it is better to think your way into a better way of. It is better to act your way to a better way of thinking than to think your way to a better way of acting. In other words, it is actually just better to do it, right? And you change mindsets as opposed to changing mindsets, which eventually change behaviors.
Yeah, that's my way of putting that. Has always been, can we just go write some code now?
Yeah, right.
That's definitely so. Moving on, we've got a little bit of an interstitial title slide here before we dive into it. But so here's do number 1. So make stuff available through self-service. Really what this is about is we've got a lot of different ways that we do things, and oftentimes one of the barriers to productivity, one of the barriers to improving cycle times and so on, is just having to wait for things, having to wait for other people to do things on your behalf. I need an environment set up. I need to set up a pipeline. I have to do some infrastructure things. I may have to do, and all of these things typically, you're rarely doing something for the first time. But oftentimes it takes as long to get something done the second, third, fourth, fifth times as it does the first time. And so one of the practices that we espouse, quite a bit is this idea of self-service, right? Take whatever you have. I mean, it doesn't have to be pretty. You can even take your existing scripts and wrap them up, do all kinds of things, but make things available in a governed way, in an easy to access way. So if I need to set up an environment to do some testing, package that up in a way that people can just do it on their own. And it's sort of what it really is the way I talk about it often when we talk about self-service catalogs, for example, is, think about it as the menu at a restaurant. If you order something off the menu at a restaurant, you get it quickly, right? If you want something, if you want the chef to prepare something special, you got to talk to them. You got to maybe they'll say no. You got to have a meeting, and the equivalent of that often is, the architecture review boards and the security SecOps review boards and all of those kinds of things that you have to go through. Well, there's really no point in going through those things after you've established a good set of practices for how you do things. At that point, you really just want to make those things available to people, so that instead of submitting a ServiceNow ticket or a Jira ticket and waiting 2 days to get something, you click a button, you get it in 15 minutes. And that really is it's all in service of GSD, get stuff done. That's really what that's about. So Gene, what do you think about those kinds of things?
Love it. The second profanity avoiding acronym. Yeah, absolutely. And I think the the notion of platforms to do things self-service is, I think, key to developer productivity, right? To do things self-service on demand, it helps create immediacy and fast feedback and flow. And in my mind, those are the conditions that allow us to actually have joy in our daily work, right? We want to be able to see the outcomes of the work we do. So thumbs up on number one, Anders.
Yeah, my anecdote for that is we worked with a customer many years ago where, back before they switched to virtualization, back in the days of physical hardware, the lag time between requesting a system and receiving it was 6 weeks. The same company then completely switched to virtualization, and at that point, their lag time from request time for a system to when they got it was 6 weeks. Mm-hmm. And a couple of years into this, they realized that was insane, and they fixed it to the point where now it became automated, and it took them only 15 minutes to drive down and get a system set up, and that works a lot better, obviously.
Absolutely, fast feedback. So here's another technical practices that enables fast feedback, which is all the technical practices around CI and CD. And so that means that we have everything under version control, that we're doing continuous builds, that ideally we're kicking off builds upon every check-in. Ideally, we're kicking in automated tests, and the goal is that when we make a mistake, we can get notification of it, ideally within minutes, worst case hours. And as opposed to the opposite, which is that if I make a mistake, I make an error, I check into version control. If the first time or opportunity that I get to know that the error occurred is 9 months later during integration testing, then the link between cause and effect has basically vanished. So two things, right? It takes a long time to find the error, right? Because is it my error, or is it the other 99 jackasses on the team? Was it my change, or was the other 10,000 changes made over those 9 months, right? And the answer is you don't know, right? So orders of magnitude more time to reproduce the problem, to diagnose it, and to fix it. So again, we want short code deployment lead times. We want fast build times, fast test times, and those are the conditions that best enable that are the practices around continuous integration and ideally even continuous deployment. One of my favorite quotes is from Martin Fowler. He said, "Continuous integration is probably is one of the most profound contributions to the practice, up there with Agile." So, praise doesn't come much higher than that. A friend of mine said, really, we want developers' best and most strenuous efforts focused on solving the business problem, and not screwing around with infrastructure. So, in other words, if we can create a great platform for developers where all this is taken care of, that lets developers focus on solving the business problems, working on the feature, right, and not futzing with things outside of the application. And I've really become, Anders, one of those fussy developers where I resent every minute, every hour, or every week that I spend, trying to connect things with each other, trying to get infrastructure working. All right. Ideally, I would just love to have a friend or a team that I can just rely upon to do it for me. Does that resonate with you, Anders?
Absolutely. I mean, I think CI and CD is really, it's really the foundation of small batch sizes, right? I mean, the CI system kind of, squeezing out a little chunk of code every time a change list gets submitted, that really kind of becomes the pump of the small batch sizes, right? If you're not doing CI, you're starting out with large batch sizes, and you're obviously not going to be able to break them down later on, after they've been submitted, and that, and it also becomes a safety net, right? When you have CI and you have automated testing behind the CI, maybe even subsequent to your kind of fast feedback, less than an hour or a few minutes kind of feedback, you may even have follow-on, testing, automated testing, continuous testing that runs. I mean, in our case, in electric cloud engineering, we're talking about tens of thousands of tests that ultimately get run in our pipelines for every single build. Follow on from the CI, but it's a safety net, right? It means I can submit something, and I can be relatively confident that I haven't broken something with what I've done, and that if I have broken something, that it will get caught, before production, before customers see it, and that's really, psychologically, I think that's an important thing, because it allows us to be more aggressive, it allows us to be more confident, and to move faster. It really is, a fundamental part of how you get software out the door faster.
Just a little brief note. I just think the notion of fast feedback is so. I'm just always surprised by how much it matters. I had this one problem I was working on over the weekend where this is some months ago, but it took me 6 minutes to complete the build, test, deploy cycle, and it was maddening trying to get something working, right? Because if every iteration takes 6 minutes, any sort of for me, the frustration levels go through the roof. And so in my case, it was the difference was actually moving OAuth onto my laptop, right? So that I could at least, I could have identical code running on my laptop versus production. And the difference was astonishing. To go from, 5 seconds, 5 minutes to 5 seconds, it went from utter frustration to actually having fun solving a problem, right? Actually, it wasn't really a problem, it was a puzzle, right? It was solving this stupid puzzle. And it just did wonders for my emotional state. I mean, I have to imagine you've had similar experiences in your career.
Absolutely. I mean, you can't get any flow going, if people sort of know what flow is in terms of, how you're operating when you're in that mode. When, if every 5 minutes you have to stop and wait for 5 or 10 or 15 minutes, or I mean, in some cases with code that's out there, that's 5 hours that you're stopping for to do a build.
Yeah, exactly.
It's impossible to get stuff done in those conditions. It really is. I mean, kudos to people who do get stuff done in those conditions, because they must have the patience of saints. Because I would be, I don't know what I would do. I would have some sort of physical symptoms as a result of that.
I certainly did. Yeah. So think, it cannot be hours. Even minutes is actually too long. Really, it should be seconds.
Yep, and I flip forward to the second slide here on this topic, just in terms of the, all of the things that you just talked about. But speed is of the essence, right? Speed and then follow on completeness with your testing and automation, so that you get the fast feedback that you didn't break anything obvious, and then you have the kind of deeper bench testing that happens afterwards automatically, that goes into a little bit more detail and make sure that you haven't broken anything subtle and those kinds of things. It's almost impossible to overstate how important that is to give a team confidence that they're not breaking things when they submit changes.
Yeah, sorry about that, Anders. Yeah, and absolutely. And so that's the list on the right. And the opposite of that is when you have lead times measured in 9 months, you have to funnel your work through 40 different functional silos. At that point, you never see the outcome of the work you do, and that is where all the sense of productivity, flow, and joy vanish. Right? You never get to see the outcomes of the work, except for the catastrophic deployment. So you get none of the positive feedback, and you get all of the negative feedback. And that is the makings of a disaster. So that's number 2. Anders, over to you for number 3.
Yep. So do take a code native approach, and this is sort of I sometimes refer to this when I'm speaking to people who understand regular expressions as star as code. Model everything. We talk about pipelines a lot at Electric Cloud. Software pipelines, software delivery pipelines, software build pipelines, all of those kinds of things. And in one sense, think of your pipeline a little bit the way that you used to think about installers back in the days of, all desktop software. Your installer was a part of your product, a very important part of your product. It was usually the first thing that the customer would see. Now, your software pipeline is, not something that your customer will ever see, but it's equally important in terms of its ability to sort of, put everything together so that you can put code in front of your customer, whether that's, on their laptop, on their device, on the website, what have you. So, being able to manage everything in your software pipeline and model it and be able to, abstract away this, kind of the what from the where from the how, the what being, your code itself, the modules in your software, the microservices or the DLLs or the jar files, WAR files, all of those kinds of things, how they're built individually and tested individually and so on, and then how they're brought together, into an application or a set of applications or a set of services, all of those kinds of things. And being able to, talk about this at a high level of abstraction, right? And so that you have an adaptable kind of system, an adaptable pipeline where, when it comes down to, hey, we have a new security scan we'd like to do, that doesn't become an 18-month odyssey of how to integrate this tool into how you build, test, qualify, release your software, but instead becomes an hour-long conversation followed by 15 minutes of, adding another stage to your pipeline and invoking a plugin to call that security tool or what have you. That you get, again, you get flow in terms of how you modify and maintain the infrastructure that delivers your code, because that's really important as well. I mean, that's, a lot of times when you get stuck in those kind of 9-month delivery cycles, it's not the writing of the code that's taking 9 months, it's all the stuff you got to do to it on the way out. So modeling everything, modeling the applications, being able to model the pipeline and what you do to the application, on its way on the path to production, and all the processes that you want to run on that, and including, we always argue and make the case with our customers that, look, okay, you're doing some manual things in your pipeline, that's fine. Make sure you capture those manual steps, those manual stages in the pipeline, because then you can start to do things like see how much time you're actually spending on these manual stages. And it's not unusual at all to see that, in a certain amount of elapsed time for a software pipeline, that, a massive chunk of that elapsed time is spent waiting for people to do manual steps. Not actually even really the doing of the manual step, which often is just, look at a number, make sure it's above a certain threshold and click approve. It really is the waiting, between these things that where you end up, losing a lot of time and, losing flow. And then, what we mean by code native is really domain-specific languages or declarative languages, right? So being able to express what you're doing to your software as code. Now, in a regulated environment, finance, healthcare, automotive, defense, aerospace, all of those kinds of things, this is almost a game changer in terms of your ability to get feedback on what your process is from your auditors or from your governance functions in the organization, and then be able to demonstrate very clearly the changes that you made and that you did make changes to that. And in some sense, one of the ways we talk about this is if you think about value streams in software, your software pipeline is your executable value stream, and it ought to be editable, it ought to be viewable, and all of those kinds of things. That's something that we evangelize a lot with our customers, and obviously is very prominent in our products. But everything as code is something that we've been all over that for the last few years, and it's paid off a lot for our customers, I think. So, Gene, any kind of insights or thoughts on that kind of stuff?
Oh, I love it. I mean, just I think we've tried to favor declarative over imperative. I love what you said about the pipeline is the new installer, and just on a slight side note, I mean, having now just loving the closure ecosystem that runs on a JVM, I think one of the big surprises is how much better the JVM is for production bundling. I mean, just compared to Ruby and Python, it just blows me away. How much more it is conducive to be able to control what gets put into production and just have all the dependencies taken care of. It's just that's actually one of the big surprises for me over the last year.
I mean, the Java ecosystem is very robust. I mean, I'm biased because I've been primarily a Java engineer for a huge chunk of my career. but I dabble in everything. Everything is a tool to me. Use it for the right thing. But the JDK and the JVM in particular it's an impressive piece of work, and it keeps getting better, which is good. And it's had competition, strong competition from other things, and that's always good. A vibrant, competitive ecosystem marketplace for this kind of stuff is very important to keep everybody on their toes.
Yeah, so code native approach, absolutely, and because it does help developer productivity without a doubt. Number 4 is trunk-based development. So this is, I guess, extends upon the CI/CD discussion from number 2. And I dug out these diagrams I just love from Paul Hammond, who just does amazing work. He has this website that's actually called trunkbaseddevelopment.com. And I just, I have so much respect for these diagrams he put together. So then let's go through some of them, right? So we have, what are the things besides trunk-based development? And Anders, I trust that some of these will bring back bad memories from your career. The first is mainline, and so this is very much often what we saw with ClearCase, where you have these big VOBs, and this is what we did when I was at TripArt for 13 years back in the the early 2000s. We did a release, and then the instant we did that, we created a new VOB, and then we had to I don't even know what the terms are for. For any changes, we had to patch another VOB. We had to bring back changes to other releases, and it was a bookkeeping nightmare. And I'm sure I'm not the only person who have had bookkeeping problems where a certain patch didn't get applied to one it's not even a branch, right? What do you call that? Separate VOB. So that is excruciating. That just shows just the huge penalty that tracking separate releases can have. So the advent of Git leads to the ability to branch very quickly, to be able to, you can branch very, very easily, but probably merging is still hard, right? And so I think that's the goal of what he describes as short-lived feature branches. We allow developers to work outside of trunk or mainline, and the goal is to merge very quickly so that the variance between trunk and the branch never diverge too much. I love that joke. What is the plural of developers? Merge conflict, right? And so that really is speaking to this problem that with enough developers and enough time, it is impossible to merge all the code back together again. In fact, just very recently, I actually created an impossible merge scenario just with me, right? Because I had too many feature branches, and it was easier just to retype all the code than it was to actually merge the code together.
What's the plural of team? Merge conflict.
Exactly. And so many people would assert that even having feature branches, it's too easy to let them go too long. And that's really the point of trunk-based development, this notion of really building into daily work, merging back to trunk. And so there are all these practices that allow you to do that, without disrupting everybody else. But it really is great because we decouple, we're taking merge risk off the table, which is astounding. I mean, it doesn't take very many of these merge hell, episodes to really get to see the light about what is so good about merging quickly. And then, once you have trunk-based development, it is actually not so far of a stretch to go to continuous deployment. So there are a lot of people who poo-poo that trunk-based development can't be done with more than a couple of people. And so for those naysayers on the next slide, it describes some of my favorite stats from Google. As of a year and a half ago, they have 30,000 developers, and they have one CI system. They are practicing trunk-based development at scale. They're doing 45 commits per workday. Almost every property is deploying at least once per day. And the reason why they can do this safely is because they have 150 million test cases being run daily. So it is astonishing to see the level of investment Google has made to essentially make this very peculiar choice, right? They've coupled everybody together. There's one CI system, one build, but you can see, the payoff. Incidentally, I find it interesting that if you take a look at these tech giants, Facebook, Amazon, Netflix, Google, they probably spend 3 to 5% of all dev cycles on dev productivity. So Google has 1,500 developers just focused on dev productivity. Microsoft has 3,000 developers focused on dev productivity. And I think that if you compare that to most technology organizations, some have zero, right? And so the point here is that, dev productivity is important, and most people are massively underinvesting in dev productivity. Greatness is not free.
Absolutely true. That's absolutely so true. And I think that the key observation here really is the test cases, right? Because you have a snowball's chance in hell of doing trunk-based development or continuous deployment type development if you don't have automated test cases, right? It's going to work. So if you had to pick one thing to do right. If you want to do things like trunk-based development, you've got to have automated test cases, because without it, it isn't going to work. So
yes,
that's absolutely for sure. And it's interesting. I remember having a conversation way back when with some engineers from Lotus, back when they were working on Lotus Notes, late 80s, 90s. Their development process at that point was engineers would go off on their own individually for 6 weeks and write code. And then they would come back together and then spend the next 6 weeks integrating all of their code together. So we've come a long way, baby.
Yeah.
That was state of the art.
That is what we did. And actually, just to tell a quick story, I remember in 2006 when I was at Tripwire, our build server broke, and our summer intern left, and we just didn't have anyone who really wanted or had interest in getting a cruise control server running back then. And strangely enough, right, if without automated builds, we didn't have really great automated tests, and but that we found out in the next release, our code integration time, right, that time merging code back together went from 1 week to almost a month and a half, right? And so it's one of these things that and we missed it, right? We just thought that was the way it went, and so it's so important to make sure that we're using these great technical practices, because if we don't, life sucks.
Yep. And really, I mean, to sort of make a manufacturing analogy, this is your manufacturing line, right? This is this is how the cars get out the other end of the factory, fully completed. If it's not working, you're not shipping, and end of story. I mean, it's really that important. When these things are broken, red lights and sirens ought to go off, because it really is that serious. To get it back, to get the wheels back on the track so that you can get going. So
number 5.
Yeah, so our next number 5 here is support cloud native alongside traditional, or to really to broaden the topic even a little bit more. It's this whole notion of if you're a large organization, if you're a enterprise of any significant size, you probably have a lot of different technology stacks that are involved. And I mean, if you think about if you're a large hotel company or an airline or something, you've got mobile apps kind of at the tip of the spear, if you will, and on the back end you've got mainframes. So you have a lot of different opportunities for what geeks like me would call impedance mismatches. Where cadences are not the same. You're not necessarily, and with apologies to folks that I know do DevOps and continuous delivery with mainframes, but that is one area where generally people are not moving as quickly, perhaps as we are in other technologies, and even so, any two technology stacks are going to have their own kind of idiosyncrasies and things that cause problems or slow things down and so on. And so, the idea here is really just talking a little bit about how you don't necessarily want to have just one pipeline, right? When especially if you're talking about loosely coupled code, and you're talking about, say, microservices, to pick a specific example, you really want to have multiple pipelines in play here that at some point are kind of merge into, as you see here, kind of the release pipeline, where you start to do more of the integration and acceptance type testing, those types of things, and these various pipelines, really part of what they're doing is addressing this cadence mismatch or impedance mismatch, so that maybe your UI is moving very quickly, or your mobile app is moving very quickly, and you can you can release, a new version of that app every few days or maybe even more frequently. And, on the back end, with where you're dealing with, data persistence and important data and information that you don't want to lose, you're probably moving a little bit slower, especially when you have to make changes to those systems. And at the same time, you don't want to have your high cadence architectures be beholden to the slower cadence of the other architectures. So decoupling your pipelines is kind of important as well, and making sure that you realize that you're going to have to move at different speeds, different cadences for different things. We'd like everything to move as quickly as is humanly possible, but the reality is they often don't. But what you can do then is decouple the pipelines and make sure that they get to move at their own cadence, and a problem in one doesn't cause a problem for the other. And this also, I think, to me, a little bit points out a problem that we have in the industry. That's not necessarily a problem we're ever going to solve. I think it's maybe just kind of the laws of physics, but we never seem to let go of technologies. We adopt new technologies, but we never retire old ones. I've been asking this question a lot the last few weeks when I'm out in the field talking to people, and it's, tell me about a technology that you've decommissioned, that you no longer use. And I'm not hearing a lot of that. So this, in some sense, this kind of pipeline sprawl, if you will, here is really a sign that, we are in a reality where we have lots of different architectures, lots of different technology stacks that we're using to get our work done, and we have to figure out how to make them work together, because you're not going to be able to do an airline reservation system with only a mobile app. You're going to need a back end for that. That isn't going to work in any other way. And then you're going to need a back end of some significant scale and performance and resilience and all of those kinds of things. And that automatically puts you in kind of a little bit of a different playing field. So the important thing here is to make sure that the cadences are matched and all of those kinds of things. And you don't put yourself in a situation where, as happened a couple of years ago with a prominent travel industry hotel firm, where they released mobile apps before the back end was released, and all of a sudden I couldn't check in to my hotel on the app, which I know, first world problem, but I couldn't check in, and literally the release notes for the next version of the app said, yeah, we released it too early, the back end wasn't ready. So keep that stuff in mind. So Gene, your comments on that, please.
Yeah, in fact, this is probably frames one of my biggest aha moments working with Jez Humble on the DevOps Handbook, was the notion of decoupling the deploy from the release. The idea is that if we can, to your mobile phone example, right? If we can get the functionality on the phone, that's a great thing, right? But then if you can just hide it behind a feature toggle so that it's not activated, you've created tremendous value, because that the functionality is on the customer phone and it can be activated at a moment's notice. You have now taken away the risk of pushing an app that actually doesn't work, that could crash the phone, right? Same thing on server-side code. The goal is to push the functionality into the production servers and know that it's working before the huge launch event. And so by doing that, we have de-risked the deployment, and now it leaves only the risk associated with the marketing execution of the release. I just think that is one of those powerful patterns, because it allows us to hold the technical teams and the business and marketing teams accountable for what they should be accountable for. Right? In fact, the whole launch failure in the Phoenix project, you could say, was a problem because it was in part due to the fact that the deployment and the release were happening at the same time, and that creates these high stakes releases where there is no going back, and you have to fix forward, and we have 6 hours before it goes live, and you run out of time. So I think this is huge. And does that resonate with you, Anders?
It absolutely does. I mean, I've frequently said to customers and prospects, if the first time you're using your production deploy infrastructure, code, scripts, whatever, is when you do a release to production, you're insane to ever expect that that's going to work, right? I mean, it really, it's really like, you have a football team, but they don't practice all week long. Instead, the practice squad practices, and then come Sunday, the team runs out on the field having not practiced all week long. I mean, what do you expect is going to happen, right? So, you really ought to, and this is something that we have a strong point of view on in our product, is that you ought to use substantially the same processing and tooling for your deployments pre-production as you are into production, so that you can debug them, treat them as part of the product. Your deployment. The deployment aspect of your software pipelines are a very important feature of your product, and you need to treat it as such.
Right on. And yeah, I love this. That game day practice, game team practice team. That's brilliantly depicted by Scott Peru from CSG. Love that.
Yep.
Number 6, promote loosely coupled architectures. In fact, this was one of the top predictors of performance in the State of DevOps Report 2017. And so what are the attributes of architecture that were so predictive of performance? It's on the next slide. So it should read, to what extent are developers able to make large-scale changes to their parts of the system without waiting for other teams? Or approval from anyone outside their team is actually the correct quote. To what extent can they do the majority of their testing without the use of an integrated test environment? To what extent can they complete their work without a lot of fine-grained communication coordination with people outside the team? To what extent can they perform deployments and releases of their service on demand independently of services that they may be dependent upon? And also, if all those things are true, they should be able to do deployments during normal business hours with negligible downtime. So, those 5 things, had one of the highest predictors of performance in the area of technical practices. And so I love this diagram that came out in 2015 that I think really shows the value of this. So on the x-axis is the number of developers, on the y-axis is the number of deploys per day. And if you see, as you increase the number of developers and low performers, the number of deploys per day goes down. As you increase the number of developers and medium performers, it remains constant. Whereas in high performers, as you increase the number of developers, the deploys per day goes up linearly. So this is a logarithmic scale, so that curve is actually linear. So it just shows how really the goal is to be able to enable small teams to develop, test, and deploy value independently, so to the customer, without having to do a lot of batching, coordinating, communication, coordinating, and often what happens in tightly coupled architectures is that your part might be done, but you have to wait for the other 34 components to be lined up, and you all have to deploy together, right? That is not conducive to productivity. Anders, does that resonate with number 5?
Absolutely. I mean, I think the picture I have in my mind of the opposite of loosely coupled is the 3-legged races that you do at fairs and that kind of stuff, where you and another person tie 2 of your legs together and then you try to run a race. That is a highly coupled kind of event, right? And that really is how that's what we need to avoid. We need to avoid being in that sort of scenario where, in order to make progress, in order to deploy, in order to release, in order to do anything, we shouldn't all have to kind of get in the same room, hold hands, and make the leap together, right? That just slows things down just dramatically, as this graph beautifully illustrates.
By the way, like we all know about the bus factor. How many people need to be in a bus to crash to kill the project? I love the lunch factor. How many people do you need to take out to lunch in order to get your work done? Is it 0 or is it 40?
That's a good one. I haven't heard that one before. So our next one, we got about 15 minutes left here, so we're gonna crank here. Let teams use their favorite tools. This really is an important topic, and it's one that we see a lot, especially in our larger customers, and especially in regulated, governed kind of industries. But requiring tool conformity and kind of having a centralized tools team that mandates what everybody should use is always troubled me a little bit, because I think a lot of the, quite frankly, a lot of the innovation and a lot of the kind of adoption of new ways of doing things and new tools for doing those things really comes from the grassroots. You know, it really comes from the people that have large amounts of curiosity. You know, they have a sense that something can be better, and you know, if only I could figure out how to do this a little bit faster or more efficient, or you know, avoid redoing that 12 times a day. You know, those are the individuals in an organization that you know, that really move the ball forward in terms of improving, you know, improving the way that we do things. And you know, oftentimes we end up with organizations that serve as gatekeepers for that. Now, you know, some of that is you know, to be realistic, is there's a little bit of a necessity for that, right? I mean, you don't necessarily want, you know, an engineer in a bank to kind of go off and freelance on, you know, kind of the tools that they use to do deployments into production, you know, those kinds of things. That's not what I'm arguing for. But what I think, you know, what I'd like to see is kind of more of a, you know, what we're calling here a guild culture, right? Where, you know, the idea is that there are people in the organization who are curious, who are, you know, who can be early adopters, who can be experimenters, who can go off and find new ways of doing things and new tools and new frameworks, new whatever to do things and do them better, and kind of vet them out to make sure that they're fit for purpose. And yeah, maybe you got to go through a process after that to kind of bring them into the fold sometimes. But you know, what we see a lot of times is, you know, organizations are using the same tools and the same architecture in the same way that they've been doing things for decades in some cases. And it's, you know, there are better ways of doing things. And if you don't have a process by which you allow people to at least experiment in that, then that's a tricky thing. And I think one of the ways to do that is to think about things in terms of abstractions and integrations and so on. And, you know, think in terms of, well, we need a way that we can edit code. You know, that could quickly turn into, well, we're all going to use Eclipse, or we're all going to use IntelliJ, or we're all going to use Emacs, we're all going to use VI. Well, why don't we just let people use what they're comfortable with and what they're productive in, you know? And you know, obviously you can extend that to a lot of different things. And, you know, there probably are, you know, there security scanning tools and so on. You probably want a little bit of vetting of those things. But you really want to nurture and feed the individuals in your organization that have that sense of curiosity and have that sense of, you know, kind of, I approach this as a craft and I want to practice getting better at my craft. And that includes learning how to use new tools, learning how to use new, you know, processes, learning how to use new algorithms, you know, or, you know, on the flip side of that, retiring old algorithms, retiring old protocols, old things that are no longer relevant or no longer secure, for example. And that's something that really has to get nurtured and kind of have that experimentation. And you really want to, you know, this is another kind of, I think, this really touches on the loose coupling a little bit as well, right? Because if you have a very tightly controlled, you know, tool chain that people can use, and it's an, you know, an impossibly difficult task to introduce something new into that, then you've tightly coupled yourself to what is essentially probably a static set of tools, and that's a dangerous place to be in, you know, especially given how fast technology moves. So, Gene, what do you think about that?
Absolutely. Like, well, as long as we're not yeah, the cross-cutting concerns, right? That's where you want some standardization. But otherwise, one of the findings from State of DevOps was that, you know, developers choosing their own tools for their areas makes sense. I love the image of tools provided by central services being kind of the Soviet era, you know, lousy tools. And so
I always think of the movie Brazil, you know, central service.
Exactly. In fact, that movie has a lot of special meaning to me, Anders, for reasons that I'll tell you about later over drinks. That's awesome.
We're here to help you.
and the number one fugitive being the rogue air conditioner repairman who breaks into people's apartments because central services won't. That's awesome.
So we've got the next topic here for Gene, number 8. We've got about 5 or 6 slides to crank through here. So I'm
gonna... So pervasive production telemetry, right? You have to see what you're doing, right, in order to deploy and certainly to restore. So if there's a religion at Etsy, says Ian Malpass, it's the church of graphs. If it moves, we graph it. Even if it doesn't move, we graph it just in case if it makes a run for it. 2011, they were tracking 200,000 metrics in production. By 2015, they're tracking 800,000. And so, yeah, the point is over the next couple of slides is that, go to the next slide. You know, here's how they deploy. Back in 2011, someone pushes code into production. They see that warnings are going up, right? And so 8 minutes later, they deploy the fix, right? So they are fixing forward, right? And only when they can confirm that everything's operating in production as designed, then they get out of line and the next person in line goes, right? And so that is how they preserve safety, even though they cranked up the number of deployments per day over many years. So that's what telemetry enables.
Yep, and I think this is, to me, this is there's a lot of parallels between this and automated testing in your CI pipeline, right? Because the orange or brown, depending on the quality of your monitor, graph here, really that you can look at that and say, well, that's when you start to have test failures in your CI pipeline, right? And then you have a next, the red line next is not a code deploy, but it's a submit to fix it, right? So you want to have that same kind of cadence in your CI system, so that you're looking, maybe you're not graphing these things the same way as you would for ops, or maybe you are, but you definitely have a sense that, we do a submit, 10 minutes later we see there's a problem in the CI system, we've got test failures, you diagnose them, fix them, and 10 minutes later you're back on track. That's how you want things to work, both in your CI at the left end of doing this, as well as on the right end when you're starting to talk about deployments and releases and those types of things.
Yes. Thumbs up on number 8.
Yep, definitely. And number 9, make your value visible, make your work visible, put it all in the pipeline. We've referred to this a little bit. I talked about kind of the notion of executable pipelines, executable value streams, and a couple of pictures here from the Quicken Loans presentation that they did at the DevOps Enterprise Summit 3 years ago, if I'm reading that correctly, just on value stream exercises they did. It's amazing to me how valuable things like value stream mappings are, or any sort of activity around that area, in terms of getting everybody into the same room and getting everybody on the same page about not how we do things in theory, but how we do things in practice. And if I had $1 for every time I'd heard somebody say, oh, I didn't know we did it that way, or, well, wait a minute, we also do this, I'd have, $50 or $60, and that's pretty good. So these things are incredibly valuable things to do. And I think as a kind of a corollary to that is, move that into your pipelines, right? Translate that into your release pipelines, your software pipelines, and kind of create that executable value stream. And this is a way that we can take that tribal knowledge, document it, make it actionable, make it editable, make it tweakable. For me, I'm a very good editor. I'm a crappy kind of blank page writer. I really have to embrace my inner, crappy first draft. When I sit down in a blank sheet of paper, it's a lot easier to edit. So, when it comes to things like coming up with a pipeline or those kinds of things, get everybody in the same room and really, get the whiteboard out or get the paper out or get those sticky notes out. Do whatever you got to do to figure out how it is that you actually do these things. And one of the ways I talk about this, and granted, this is the audience for this kind of illustration is somewhat limited, to people that watched a lot of television in the 70s and 80s. But if you ever watched Schoolhouse Rock, they had a great episode, a great little thing called How a Bill Becomes a Law. And it sort of anthropomorphizes a bill in Congress and the journey that it takes through, the House, the Senate, getting signed by the president, all of those kinds of things. And really what I think people should do is, put a GoPro camera on the head of your source code, and then record the path that your code takes as it makes its journey through, being, first submitted by an engineer to when it's in production, providing value for a customer, and really understand, how much of that time is it sitting around, how much of that time is it getting tested, all of those kinds of things. I think that is something that organizations that understand this and know this, they are the ones that are in a position to make improvements. They are the ones who are in a position to improve cycle times, to really be able to start to understand where the delays are, where the problems are introduced, all of those kinds of things. Something that we have a strong opinion about, not just when we talk, but also in our products. Just make it all visible. If it's manual, put it in there, right? Track everything. Gene, what are your thoughts on that?
Yeah, make work visible. How can you work on it if you can't see it, right? So without a doubt, 95% of total cycle time is dominated by wait time. That is, unmanaged. That is a fact of life. Lucky if you get to 95%. So thumbs up on number 9.
I remember talking to you once. And talking about it, I just come back from a prospect visit, and they had just done a value stream mapping, and 90% of their time was in wait states. And you said, "Oh, that's actually pretty good."
Yeah. It was actually the same in manufacturing too. So which is interesting, right? Because the work's a lot more repetitive, shorter cycle times, etc. So that
Absolutely.
takes us to number 10, the last one. Treat security the same as quality, right? I love that. We're now showing that security is a subset of quality. That we can use the same technical practices we use to address, all the problems that we care about DevOps, and just extend them to DevOpsSec or SecDevOps or DevSecOps. And so here's a great diagram that came from John Willis that is based on a diagram that Damon Edwards first created, just showing how we can integrate fully information security objectives into our CI/CD pipelines. And we found in the State of DevOps report that high performers, because they're doing these type of things, they spend 1/2 the amount of time remediating security issues. So I just thought that was a lovely, lovely finding. And I guess Anders, on this last slide, I'm starting to now just talk a little bit about this project I've been working on now called the Unicorn Project. It's a follow-on to the Phoenix Project. And the Phoenix Project had the 3 ways, the 4 types of work. And I think everything's really going to hang off of the 5 ideals in the Unicorn Project. And it really is, simplicity, right? We want architectural simplicity as opposed to complexity. Have work be fast so it creates focus, flow, and learning instead of being boring, dominated by weight and burnout. Value innovation and achievement versus process and compliance. Safety 2, when something goes wrong, do we ask what caused the problem, or are we on a witch hunt to find who caused the problem? And really being customer centric, right? Meaning that now we care about outcomes for the customers as opposed to really caring about our functional silo. So I just found, when you do books like this, you just hope that, you delete everything that doesn't have to do with these 5 things, and you just hope that there's enough left to have a book. So that's where I'm at right now. So with that, I think that takes us to the finish line for you. Take it away, Anders.
It does, and just a quick summary here before we have a couple of minutes left over for Q&A. The 10th here being kind of a reference back to the idea of, how do you take somebody camping for the first time, right? Would you rather have them, be in this kind of a tent or in a, soggy, Boy Scout, pup tent kind of thing? This is kind of the analogy we're pushing here a little bit in terms of, create a soft landing when you're making these kinds of changes. And a lot of the technical practices we've talked about here are ways that we can reduce complexity, reduce friction, reduce wait times, uncover work that's hidden, all of those kinds of things, really allow us to get our stuff done. And I'm going to fly through these so we get at least a couple of questions in. A couple of just things to talk about here. We've got a new initiative that we've been working on for quite a while here. We call Electric Cloud University, in partnership with the DevOps Institute, and it's subscription-based training and certification for DevOps types practices. Really cool kind of stuff. Check it out. And it's really, there's also another report that we want to talk about here in terms of upskilling, the Enterprise DevOps Skills Report Survey, again, also with the DevOps Institute, talking about, what are the skills that we need to, acquire, learn, and get better at to really be good at our jobs. So I'll a shout out for those there. And then hopefully a couple of questions we could get in here before we shut down.
We've got 2 minutes to the top of the hour, so let's make time of the essence. Gene and Anders, fantastic, goes without saying. Also a quick reminder about DevOps Enterprise Summit in London. We'll be there from DevOps.com as well. But we've got a lot of questions, and we'll try to get to them in email.
Sorry, Anders, we screwed up.
No, it's okay. Look, I think I'd rather listen to you guys than me ask questions. But a lot of the questions kind of focused around one particular idea, and that was a mix in teams, mixing of manual and automated processes. Is there a benefit of putting manual processes like code reviews, etc., into the pipeline? So if we can maybe get an answer to that, and we'll try to do the rest in writing.
Yeah, I'll do a quick one on that. I mean, I think you have to be a little bit careful because you don't want to kill those kinds of things with too much process, and bookkeeping type things. I would say certainly kind of ongoing code reviews that you would do before you submit things for CI. I'm not so sure that I would necessarily put those in something that you would throw in as being an official part of a software pipeline in terms of the automation and bookkeeping keeping around that. Maybe you would do that for patch pipelines. If you're working on doing patches for released software on a release branch, assuming maybe you're not doing trunk-based development, those kinds of things, they may be appropriate there. Or if you're doing a security mitigation or those kinds of things, you may want to have that be an official part of the process. But I wouldn't want to, kind of burden everything that we do as engineers with, kind of the bookkeeping aspects of it. I think that might be carrying it too far in that particular thing. That said, if you have manual steps in your pipeline or in your value stream, by all means put them into the pipeline. Especially if they are taking significant amounts of time and are part of, what's delaying things. So a little bit of a quick answer to that one there, Gene. I'll give you a chance to respond to that.
Yeah, I think I don't have much to add to that. I agree with you, right? Manual steps. If there's a way to decouple that from the daily work of developers, even better, because really we want the fastest feedback to developers, and we can cherry pick with the ones that actually have to go to the next step. No point in burdening every commit with that.
Yep.
Guys, we're over the top of the hour. We got to run. Before I do, for those listening live or on Memorex, quick reminder, does at the end of June, DevOps Enterprise Summit London. I think it's June 25th to the 27th. And the release today of the new State of DevOps report.
Yay.
Dora folks, now Google Cloud. You know what? The more information they get, the better that report is for everyone. So go check that out. Please do check out some of the other great resources Anders and Gene mentioned. Of course, you can listen to the webinar again and again. It is being recorded. Anders, Gene, thanks as usual for great webinars. Many thanks to Electric Cloud for sponsoring today's webinar. Most of all, thanks to all 236 of you who've stayed here till the bitter end to listen to this and to the thousands who registered. Have a great day, everyone. Alan Schimmel, DevOps.com. We'll see you soon on another webinar.